Hello, and welcome back to Chapter 9. Today we're going to look at Section 9.6, which deals with solving rational equations. First of all, a rational equation is going to look something like this given equation right here. What you'll notice is we're essentially adding or subtracting fractions, okay, and we have polynomials in either the numerators and or denominators. Now we're going to take the same approach that we have in sections 9.4 and 9.5. To solve rational equations, we need to, first of all, find the least common denominator, and then we're going to multiply each term by that common denominator. And the reason we want to do this is because we want to get rid of those denominators. Once I get rid of the denominators, we no longer have a fraction. And I don't know about you guys, but if I don't have to work with a fraction, that would be my preference. So let's go ahead and look at our first example. Our first example says to solve 3 divided by x minus 1/2 equals 12 divided by x. As I mentioned before, the first thing we want to do is we want to find a common denominator. Well, I see I have a denominator of x, a denominator of 2, and another denominator of x. So if I get my least common denominator, I see that I have 2x. Now what I'm going to do with that 2x is I'm going to multiply each term out of my original function by that least common denominator. So to set this up, I'm going to go 2x times 3 divided by x minus 1/2 equals 12 divided by x. And then what I'm going to do is I'm going to distribute this 2x onto the 3 divided by x, this 2x onto the 1/2, and this 2x onto the 12 divided by x. So let's go ahead and do that right now. So if I go 2x times 3 over x minus 2x times 1/2 equals 2x times 12 divided by x, what I notice is, and let's go ahead and write all of these fractions, these 2x's are really all over 1, so that when I multiply fractions, I see that my x right here is going to cancel out with this x, and that's going to leave me with 2 times 3, which is 6 divided by 1, minus I have a 2 in this numerator and a 2 in this denominator, so my 2's are going to cancel, and that's going to leave me with x divided by 1, and then equals 2x times 12 divided by x. My x's here are going to cancel, and I'm left with 2 times 12, which is 24 divided by 1. Now when I go to simplify this, 6 divided by 1 is really 6, x divided by 1 is really a negative x, and then 24 divided by 1 is still 24. So to go ahead and solve for x, I see that I can go ahead and subtract 6 from both sides. That's going to leave me with a negative x is equal to 24 minus 6, which is really 18. I want to get rid of that negative on the x, so x is equal to a negative 18. And you can double check your work by plugging that negative 18 in back to your original equation, which is right here. Now let's look at example 2. We want to solve 5x divided by x plus 1 equals 4 minus 5 divided by x plus 1. So I'm going to go ahead and find my least common denominator. And in this case, I see that I have an x plus 1 right here. This 4 is really being divided by 1, so I can show that for right now if I want to. And then I have an x plus 1 here. So really, my least common denominator is x plus 1. So I'm going to set this up and multiply each and every term by my least common denominator, which is x plus 1 times 5x divided by x plus 1, which equaled 4, and I'm going to put that over 1, minus 5 divided by x plus 1. If we distribute this onto each and every term, I end up with 5x divided by x plus 1 times x plus 1, and this is really over 1, which equals 4 over 1 times x plus 1 over 1 minus 5 divided by x plus 1 times x plus 1 divided by 1. Now to simplify, I see that I've got some products of fractions, and I notice that I've got some common denominators. So I see that this x plus 1 is going to cancel out with this x plus 1. Nothing's going to cancel out in this fraction, but I have an x plus 1 here and an x plus 1 here. So when I rewrite everything with what I have left, I see that I have 5x divided by 1 is equal to 4 times x plus 1 minus 5. So if I go ahead and I simplify everything, I see that I have 5x is equal to 4x plus 4, and all I did was distribute this 4, minus 5, or 5x is equal to 4x minus 1. Now I want to isolate all my x terms on one side, so I'm going to go ahead and subtract 4x from both sides, and I see that I have x is equal to a negative 1. Now if you recall, your original function said to solve 5x divided by x plus 1 was equal to 4 minus 5 divided by x plus 1. If I plug this negative 1 in down here into this x or this x, I'm going to have negative 1 plus 1, which is going to give me 0. And if you recall, if I divide by 0, I get an undefined answer. Therefore, what I just solved for, this x equals a negative 1, this is an extraneous solution. And if you recall, an extraneous solution means it's something that I can solve for algebraically, but when I go back and I substitute it in, it's not really going to work. So in this case, this tells me I have no solution for this problem. So please double check that your answers actually are truly solutions. Next, we have example 3, which says to solve 3x minus 2 divided by x minus 2 equals 6 divided by x squared minus 4 plus 1. Just as we did back in section 9.3 and 9.4, I'm going to ask that you go ahead and factor any denominators, and I see right here I have the difference of two squares, which is going to give me x plus 2 times x minus 2. And I want to factor if I can, because sometimes it makes it easier to find my least common denominator. By doing that, I see that my least common denominator is really x minus 2 times x plus 2. Because this denominator already has the x minus 2 like this one does, I just need to also incorporate the x plus 2. So I'm going to rewrite my problem with my least common denominators out front. So I have x minus 2 times x plus 2, and I'm going to multiply that by 3x minus 2 divided by x minus 2, which is equal to 6. And I'm just going to rewrite my denominator for this one as the factored form, which is x plus 2 times x minus 2 plus 1. Now when I go to simplify, I'm going to distribute these two terms onto this term, and this term. So I'm going to end up with x minus 2 times x plus 2 over 1, and I'm going to multiply that by 3x minus 2 divided by x minus 2, and this is going to be equal to x minus 2 times x plus 2 over 1 times 6 divided by x plus 2 times x minus 2, and then I have plus x minus 2 times x plus 2 over 1 times 1. So what's going to happen is I'm going to be able to cross off numerators and denominators. I have an x minus 2 here and an x minus 2 here. That's going to leave me with x plus 2 times 3x minus 2, which is equal to, I see I have an x minus 2 and an x minus 2 here, an x plus 2 and an x plus 2 there. So that's going to leave me with 6 plus, and then down here I don't have anything to cancel out because I was just multiplying by 1 for this term. So now I'm left with x plus 2 times x minus 2. So now I can go ahead and simplify. X times 3x is 3x squared. X times a negative 2 is minus 2x. 2 times 3x is plus 6x. And 2 times a negative 2 is a negative 4. And this is going to equal 6 plus, I have x plus 2 times x minus 2. I know that's going to give me x squared minus 4. So now when I go in and I simplify, I see that I have 3x squared plus 4x minus 4 equals x squared plus 2. I want to get all of my like terms together on one side since I have a quadratic equation. So I'm going to subtract this x squared, which is going to give me 2x squared plus 4x, and then subtract this 2, which is going to give me a negative 6, equals 0. I can factor a 2 out, and I'm left with x squared plus 2x minus 3 equals 0. And I can now factor that. So I have 2 times x plus 3 times x minus 1. And this equals 0. So now I found that x is equal to a negative 3 or a positive 1. And if I go back and plug that into my original equation, which was 3x minus 2 divided by x minus 2 was equal to 6 divided by x squared minus 4 plus 1. If I plug my negative 3 in and I plug my 1 in, you'll see that both of these actually work, so these are both solutions, and I can include both answers then in my final answer. At this point, if you would please pause the video and try to work this problem out on your own, I think it'd be most beneficial to you. When you're done, go ahead and turn the video back on and we'll work through the solution together. The first thing you want to do is you'll need to find your least common denominator. And in this case, that is 2x. Then I'm going to multiply each of the 3 terms by my least common denominator. So I'll end up with 2x times 7 divided by 2 plus 3 divided by x equals 3. And remember, we're going to distribute that 2x onto all 3 terms. So this is going to give me 7 halves times 2x over 1 plus 3 divided by x times 2x over 1 equals 3 times 2x over 1. In the first term, I see that my 2's are going to cancel, and it's going to leave me with 7x plus this x and this x are going to cancel, so I'm left with 3 times 2, which is 6, and then equals, I have nothing that's going to cancel, but I have 3 times 2 is going to give me 6x. Now if I get all of my x terms on one side and all my constants on the other, I see that I have x equals a negative 6. Again, I would like you to pause the video and try to work out the problem of 3 halves plus 4 divided by x minus 1 equals x plus 1 divided by x minus 1. Your first step is to get a least common denominator. and that's going to be 2 times the quantity of x minus 1. And we are going to multiply that common denominator by each term. So I'm going to multiply that by 3 halves plus 4 divided by x minus 1 equals x plus 1 divided by x minus 1. So I'm going to distribute that onto all 3 terms, and I'll end up with 3 halves times 2 times x minus 1 divided by 1 plus 4 divided by x minus 1 times 2 times x minus 1 over 1 equals x plus 1 divided by x minus 1 times 2 times x minus 1 over 1. And again, we'll go through and simplify anything we can. So my 2's are going to cancel, and that's going to leave me with 3 times the quantity of x minus 1 plus x minus 1's are going to cancel here, leaving me with 4 times 2, which is 8. And here I see I have my x minus 1's are going to cancel, and I'm left with 2 times x plus 1. So now I can go ahead and simplify this. So I end up with 3x minus 3 plus 8 equals 2x plus 2. When I go ahead and continue to simplify, I have 3x plus 5 equals 2x plus 2. I'm going to move this 2x over, and that's going to give me x. Move this 5 over to the right-hand side, so x equals a negative 3. I just need to double check that when I plug in x equals a negative 3 into my original equation, that it works. And you'll see that if you evaluate the function at x equals a negative 3, you actually get negative 1 on both sides. So this is a valid solution. The last thing that we're going to look at is when we have a special situation, which is when we have a single rational expression on each side of an equal sign. If this occurs, in other words, we're looking at one fraction equals another fraction. If this happens, then we can use the method of cross multiplication. Now, if there's any more than one term on one side, whether it be the left or the right side, you cannot use this method. Only if there's one rational expression on the left side and one rational expression on the right side can you use this method. So let's go ahead and look at our next example, which is example 4. This method says solve 2 divided by x squared minus x equals 1 divided by x minus 1. Now, if you notice, I have one fraction on the left side and one fraction on the right side. Because of this, I can actually use the cross multiplication method. The cross multiplication method says that I can take the 2 of my numerator and multiply it by the x minus 1 of the other denominator. So I end up with 2 times x minus 1 equals, then I'm going to do the same thing, except I'm going to use the denominator of my first fraction and multiply it by the numerator of my second fraction. So I end up with x squared minus x times 1. Then I'm going to simplify. 2x minus 2 equals x squared minus x. I'm going to go ahead and simplify this farther down. I'm going to move this 2x over to this side, this negative 2 over, so I end up with x squared minus 3x plus 2 equals 0. This is something that's factorable. So I see that I have x minus 2 and x minus 1 equals 0, or x is equal to 2 and 1. When I go and plug these in, however, I see that if I plug a 1 in, I'm going to end up with a 0 in my denominator. If I plug a 2 in, I should be all set. So the only true solution then is going to be x equals 2. And I can cross off that 1 because 1 is an extraneous solution. Again, please pause the video and try to do this problem on your own. Once you're done, we can double check your answer. Let's try the cross multiplication method with this problem because I have one fraction on the left and one fraction on the right. So to do this, I'm going to take and multiply a negative 4 by x minus 3. And I'm going to set that equal to x plus 3 times 5. Now I can go ahead and simplify. So I end up with a negative 4x plus 12 equals 5x plus 15. If I group all of my x terms on one side, all of my constants on the other, we will end up with, and I'm going to move my negative 4x over to the other side. So that's going to give me 9x. And I'm going to move my 15 over to the other side. So 9x equals a negative 3. When I solve for x, I end up with a negative 3/9, which is equal to a negative 1/3. So I'm just going to go back and double check to make sure that my work is good. And when I plug a negative 1/3 in, I see that I actually end up with a negative 1.5 on both sides, so that tells me that my work is good. And this will conclude section 9.6.